Hi, everybody. Thanks for listening to Kung Fury for a moment there. The Hoff is my soul animal. So what we're going to do today is we're going to build React from scratch. And I really mean from scratch. No dependencies, no anything. And unfortunately, my notes were up there, and I had a joke about making a joke. So if you read it, just pretend you didn't. I don't actually have a joke is the joke. So I'm going to tell a story about this GIF, and it's GIF with a hard G. So I tried to download this in a high-resolution version, and it was 77 megabytes. And I kind of broke the hotel Wi-Fi for a moment. And then when it finally did download, it crashed Chrome. So this is just a 4 megabyte version. So I hope you've enjoyed watching it 7 times. So as Jameson said, my name is Paul. I go by ZPal on the internet. I've been working on React at Facebook for the last few years. And if you've seen that ugly mug, that's me. I've been using it on GitHub. You might recognize me. If not, hi. So this is going to be dense. So I want to make sure we review some of the terminology, because it definitely gets confusing. We have a few sort of pieces of this. We have component classes. These are what you define in your React components. You have React.create class. You have React.component as a base class to extend. What we also have are instances. Instances are basically anytime you new up, React news up one of those classes, it creates an instance. And we put a bunch of backing store data in there. You should never be newing up these things yourself, just as a reminder. We do that for you. And if you're ever confused about this is the this that has set state. So that's that one. And last but not least, we have elements. Elements are what you create in your render function. You return them. They don't have any instance information. They're super lightweight. There's a type field and a props field. And that's really it. You should never really need to worry about that. JSX transforms to those. And if you're not using JSX, that's fine, too. So I promised we'd build React. So let's just go do it. OK. And we're done. Nope, that's not it. So we're going to actually build it. But the first thing we need to do, because this is JavaScript, is we need to pick a name. So let's do that. So let's call it dilithium, because dilithium powers the warp drive. And we want this to be fast, and it's great. I actually picked the name and designed the slide before I did anything else. So I had to keep it in there. Now, the second most important thing is to design our APIs. React has done the hard work for this already. We're just going to take a couple of those. So we have our top-level API. We have create element. We have this base component, and we have render. Create element is going to work exactly like React.createElement, down to all of the stupid nuances it has. Component is our base class. We're not going to support stateless functional components. We're not going to support create class. It's way too much to try to do in 24 minutes or however much time I have left. And we have render. We need to do that to make sure it actually goes in the DOM. In the component class, we're going to have a constructor. We're going to make sure we have render. It's kind of important. And we want to make sure set state works. And we also need to support props and state. So the third most important thing is to build an example. And I think we call this test-driven development. We build this first, and then it runs. And you just press refresh a lot. So all we have is a title there. We have this square that is red and just keeps becoming more red until it resets, and a counter. It's not super complicated, but it sort of covers the few things we need. So here's the code for that app. It's a counter button. Originally, I was going to make events work. That took way too long. So I kept the name for some reason, it's not a button. There's no buttons. So we have our constructor, we pass in props, we call super, we call this.state, we set that to our initial state, and then we're just going to update the state super, super often. And we have a render function. We're going to use the title that we pass in as a prop. We're going to create this other component, color swatch. We're going to pass our state as a prop to that, and then we're just going to render the count. And the color swatch component is just a div. We're going to set some styles on it. It's going to be this box that everyone loves boxes that just becomes more and more red. And of course, we need to render it. So once again, that's what it looks like. Okay, everybody ready? Let's go. Full speed ahead. Let's start with create element. Create element is, like I said, it's our smallest unit, so hopefully it's the easiest to explain. We have the same signature as React. We have our type, we have config, we have children. Type is going to be either the class itself or a string. Config, we're not calling it props yet because it's not quite props, and we have children. So we're going to make a copy of the config object and assign it to props. We're going to assign children next. React does a little bit more work here to make sure keys and refs work. 22 minutes, so definitely not making that work. Props.children. This is one of the first optimizations that React starts to make. If you've ever hit that situation where children is sometimes an array and sometimes not, that happens right here. And we just do it to avoid some extra array allocations, and it makes some things easier to reason about and a lot of things harder. I'm sorry, but it's fine. And then we need to return this. Okay, jumping straight into the DOM renderer. This is our dilithium.render, our react.render. We have a bunch of bookkeeping we need to do. We have this thing that we're going to set on the DOM node itself. And in this module, we're going to end up creating a lot of instances. And so we need to store those. And excuse my return true and return false. So, render. It's only a few lines of code, right? It's super simple, right? So this, what we're going to do here is determine if we're updating a node. That means we already have an instance that we've rendered in there. Or if we're going to create a new instance and mount it. And I'm going to use the term mount a lot, mount and update. Mounting really describes that initial creation and instantiation and rendering of those instances. Okay, so let's jump straight to mount, which, again, initial render. We're going to instantiate these components. At this point, we only have a single element, which has a type field. We use that type field to basically new up that instance for you. This abstracts away some of the differences between DOM components and composite components. Those composite components are the ones you defined, and sort of hides that away for you. We end up doing a lot of bookkeeping on that instance, and then more bookkeeping. I'm going to say bookkeeping a lot. I'm sorry. And then we're going to mount it. And we call into this thing called the reconciler. The reconciler is the sort of most complex and abstract part of React. That's what we're going to spend a lot of time talking about. But at this point, all it does is return a DOM node. And so this keeps this code nice and short, and we hide away the complexity. And then we're just going to go put it on the DOM node. That's important. So going back to this for just 1 second, this is going to be super, super recursive. Recursion's important, it turns out. And if you've ever seen those stacks in React when there's an error and it's 17 million frames, this is why. So update. Some more bookkeeping. We need to grab the instance that we previously rendered, because what we're going to do is try to update that instance. And that's what we're doing here. So we compare the current element that was previously rendered to the one that we're receiving now. And we have this method called shouldUpdateComponent, We're going to visit that in just a second. And it determines if this can be an update or if it can't. If it can be an update, we're going to update it. And again, these things are weird, namely weird, so we're going to just pass that into the reconciler, let the reconciler do the work. It's called receive component. It's actually receiving an element. This is like a code mod we should have done 3 years ago and haven't. I'm sorry. And if we have a new component, if we're not allowed to update, we're going to unmount the current one and mount the new one. And so this method's actually super interesting. I mentioned recursion. We're basically going to do this exact thing at every step in the tree. And it's obviously going to get a little expensive, so we need some shortcuts. Should update component is our first shortcut. And don't confuse this with should component update. We're bad at naming things, I'm sorry. So what we're going to end up doing here is just determine if we can update this current instance. Instances have this type field. They were created if you're creating a counter button. You can't render a color swatch at the same place. So what we need to do is look at that type field. And so one of the main power of this shortcut is that we can throw away entire subtrees. So if you're going from a div to a span, there's a good chance all of the children are probably going to be updated or changed. And so we're just going to stop and say, nope, throw that away. Same with composite components. And all we really use is that type field. React does it, there's a little bit more complication in React itself, where we also use keys. Again, we're not doing keys. And so this really speeds up a lot of things. There's a great blog post that Christopher Chateau wrote a while ago that really explains how this works. I encourage you to go read it. All right, back to the reconciler. We called into this a lot from our renderer, so seems like the next place we should go. First up, we have mount component. Mount component takes a component, and this actually generates the DOM node. Except you can see it doesn't actually generate the DOM node. It calls into the component, its instance itself. And we get a DOM node back. And so we actually have this abstracted away here because we use the same reconciler in React Native. So we need this to work across platforms. So markup here might be a DOM node. It might be an Android view, an iOS view. The reconciler itself doesn't care. It passes this back up to the renderer. Again, receive component, poorly named, but what we see here is another shortcut. So when there are some cases where you can optimize, you can use object literals as elements, and in that case, we know that you're updating to the exact same element, so we don't need to do anything. We're going to take a shortcut. And again, if we're not taking the shortcut, we're going to defer to receive component on the component instance itself. Unmounting, again, we're going to just defer to the component. And then there's another method I'm going to skip. So we have this internal component lifecycle. And so we just called a bunch of methods from the reconciler. So we need those to work. And in order to make those work, let's explain the actual internal component lifecycle. So we have a constructor. We've instantiated our component. This is how we do it. The next thing that happens is we mount the component. This generates the DOM nodes or the React Native views and doesn't actually do anything with them, just returns those up. Can also receive updates. These are the partial updates you might get from renders that happen above this component. Your parent component renders, passes new props. You can update a component. This is mostly an internal API. Even the reconciler itself doesn't really call it. And then you have unmounting. It's very important to make sure you unmount components so that you release all that good memory that you're using. OK, component API. We're finally here. So this is going to be the component that the base class that you extend. and it's just a class. Yay, classes. So we have a constructor. We only have two public APIs. We have the constructor, which, again, you never really call yourself. You only ever call super inside your constructor. We're going to set some fields. We need props, obviously, and a bunch of other things we're going to use later. The last step is to make sure we actually have a render function in this class. The other public API is setState. SetState, as hopefully many of you are aware, takes a partial state. And React actually is far, far, far more complicated here. I've simplified this to that, which is 5 lines of code. React has hundreds. It needs to support batching. And this is where batching starts to come in. React actually builds up a queue of partial states, and then you can call setState. Immediately after that, it just adds things to the queue. And we don't actually flush all of this out immediately. But we're going to here because synchronous code is far easier to look at. We have another helper method for our constructor. We just need to make sure we store the current element. We use that in a bunch of places. You've already seen it in our shouldUpdate component. Mounting. Again, mounting. So this is where the magic starts to happen. So we're finally calling our render function. It's kind of important. And for our composite components, we have another little shortcut. We know that we can only ever return a single element from render. To probably the dismay of all of you, you cannot return an array from render. And this is exactly where it happens and why. Technically, it's probably possible, but much harder to support, so we'll just keep React fast. So this is where we would call the component will mount lifecycle method. And then we need to actually instantiate the rendered element. So if you remember back to our top level mount, this starts to look very similar. And then recursion. So we generate our DOM nodes farther down the tree, and we bubble those back up. Receiving is boring. Updating. So we just called update component from receive component, and this takes a next element. For state updates, this is actually going to be the same element, and so we hit a little, not so much a shortcut, but this is where we can determine if we're updating via a setState call or a render above us. And so we can call our lifecycle methods. Component will receive props. And you love lifecycle methods, so here's 2 more. Should component update happens right here, we have the pending state, we have our props that we're getting passed in, and we can pass those to your should component update method to determine if we need to actually continue. And then some more life cycles. And then we have more bookkeeping. We need to make sure we update the current state before the next step. Because the next step, we're going to call render. Again, it's just this feedback loop. And again, just like a top-level render, we determine if this current return value of render is something we can use to update the rendered instance. And so on and so forth, so we just recurse. If you get tired of me saying recursion, there's probably only like 10 minutes left. So we're gonna, if it's not an update, this looks exactly like the top level update where we've determined if we can update or not. We can't, so we need to go unmount and replace the DOM nodes. I said that this is supposed to be a base class you use across React Web and React Native. I cheated here, so this is actually just calling directly into the DOM helpers. You wouldn't do that in real life. OK, DOM component wrapper. I'm wrapping this up soon. So we actually have a helper class, wrapper class that we use for our internal instances. These are never exposed to you. Previously, we used to do this via refs. Refs used to give you this internal instance. We don't do that anymore. It's better that way. You actually get DOM nodes as refs. But we have mostly the same API. So we're going to extend this other base class called MultiChild. We'll get to that in a minute. We have a constructor. Again, we're passing in an element. We're calling super. We're doing some bookkeeping stuff. We need to make sure we store current element. We're going to do a lot of the same comparisons. Mounting. So mounting is actually a little bit different here. Because we're finally at this bottom layer, we can do the things that need to happen, like creating the DOM node. So we're going to do that here. It gets far more complicated in real React. Creating DOM nodes for SVG, you have to do something different. You have to make sure you create them in the right namespace. For custom elements, you need to pass an extra field. We won't do all that. So we have update DOM properties. This is exactly what it sounds like. We're going to go update DOM properties. At this point, we don't have any, so we're just going to go set a bunch of things. And then create initial DOM children. We're going to look at that a little bit more closely. So this ends up being the lead-in to MultiChild. And it starts getting weird, unfortunately, but it makes for more things for me to talk about. So we can take a shortcut right here. If our child is a single child and it is a string or a number, for example, we're setting the title and we're showing the current count, that's this case. We're just going to go and set the text content of that node. In React, this is actually, again, more complicated. There's a bunch of bugs around setting the text content. We actually have a wrapper class to make sure we can track updates. In React previously, version 14 and below, that was the wrapper span that you saw all over the place. It's now just text content with some comment nodes in there to help differentiate. But we're taking an even bigger shortcut. The interesting case is right here, where it's either an element or an array of elements. And so this is similar but different to the regular component case. We no longer know that we only have a single child. It can finally be an array here. And while that might not seem immediately clear, happy to chat with you later, we don't have time to really explain why that can only happen here, and why only this class needs to worry about multiple children. But trust me. So mount children, like I said, it looks a lot like mount component. And for good reason, we're going to effectively do the same. We just have a lot more things to start tracking. So let's recurse again. So MultiChild. We have this mount children API. That's what we just saw. We have update children. We have unmount children. This is sub-in children for component, and it's virtually the same thing. And this is the last slide with code. So it's also the worst code. So this is where we actually start to see the real magic. I mentioned magic before, but this is where the real updates happen. We build up this list of update operations that we need to do. And so these are the things that we have insertions, we have moves, and we have removes. And so these are abstract at this point, and the goal is that these bubble back up to the native layer, and that layer, which we just came from, can handle the actual DOM operations. We're going to cheat a little bit and do that directly because it's faster. So we represent these update operations as sort of just lightweight objects. Again, similar to elements, lightweight, but it's just this thing that we use internally. So the type field is really the only important thing to have. We need to distinguish between inserts, moves, and removes. There's a bunch of other fields on there that we need as well for the actual operation to happen. You need to know what node you're going to insert, for example. So we have move, again, looks very similar. Remove, again, similar. If you're familiar with CRUD, it's basically the same concept. So, mount children. So, we're not actually going to look at the implementation of child reconciler because I love you guys. That's not fair. But basically what it does is the same thing we've been doing. We're going to instantiate a bunch of children. The difference here, children components. And so the difference is that we actually end up with an object. And this object is a flat object. So the props.children can be arrays of arrays of arrays. And we have to make sure that we update those arrays independently and optimize those operations. And so what we end up with is this rendered children object. It's going to look something like this. The left-hand side is this set of keys that are based on the depth in the tree, and if you remember React 14 and below, we had data React ID. That's exactly those. And so if you provided a key yourself, you would see .0, .0, I think $, and then 17 million characters for your UID, and your DOM got really crazy. But the point is that these are unique, and they represent the depth of the tree at the same time. And at this point, we've instantiated them via instantiate children, but we haven't mounted them yet. So we're going to loop over this and just mount them. We're building up a flat array because we have a flat object now. And the DOM works better with just a flat bunch of children. So that's all we're going to do here. And remember, recursion. So this mount index is important. So this is the position in that array. And when we do updates, we need to track moves. And so what we store on each of these instances is this index, this current position. And then we bubble up our DOM nodes. So unmounting is actually nice and simple. We just loop over and we call unmount. It's boring, but more recursion. Updating. I called it the bread and butter of React because I really love bread and butter. So it gets a little complicated in here. So we call this next children. Next children is actually an array of elements. This is the same sort of thing we get back from render that we passed in earlier as well. And so what we're going to end up doing in here is determine which instances are being removed, which are being inserted, and which are being updated. The child reconciler, which again, we're not going to show the code for that, does the hard work. It does the search for removals. And so that's what's happening here. Or not right here, sorry. So this is actually very similar to instantiate children, except what we have is elements themselves. So we don't have a current element field. We have a type. You have your divs, your spans, et cetera. And so we don't instantiate yet because we don't know that we need to. We're going to pass these through to our child reconciler. And so we need to do some tracking to figure out which ones are being removed and which ones are being inserted. So that's what we have, those two tracking objects. We pass these through. Update children is a very mutative API. Mutation's bad, except when it's fast. So previous rendered children at this point, we don't do anything to it. If we've detected in that child reconciler that we are replacing nodes, we are going to unmount. Yes, we unmount that. Yes, sorry. We unmount that instance. Like I said, this code's confusing. We unmount that instance, and we track it in removed nodes. Next rendered children starts as an object full of elements, ends with an object full of instances. Not confusing at all. Mutation, it's great. So it's an optimization we make so that we can pull the previous instance and put it into this new object. And then we end up using that new object at the next stage. And the next stage is to build up this array of operations that we're going to do. So we're going to do another loop. James is going to talk about loops maybe later. I hear loops are good. So we're going to loop over children. We need this child key that we have, and we need the index. Index, again, is important for our order. So we have a previous child and we have our next child. And we're looping over these two objects. Next child is the new one. But it might be the same as the old one. And this is where it's just an update. We're just going to set some properties on it. We're not going to unmount and remount. And so we need to record a move, but not always. So if we're moving to a position that's lower, at a lower index in node.children, then we don't actually need to do anything. So this is another little shortcut. There's no point in moving something if you're going to remove all the things that are in front of it. So we skip. And the only other case we have to handle right now is insertions. So we got a new child. We need to do some bookkeeping to make sure it goes into the right place. So that's what's happening there. And then we record an insert operation. And removals, again, this is a lot like unmount children. We just loop over and we remove them. At this point, we're actually recording remove operations. We want to make sure this happens all at the same time and that we're not removing things and then randomly inserting at a separate point. And then we just update our internal state. And last line of code. This is it. We're going to process that queue. This does all the actual DOM operations. It's not really interesting to talk about today. More than happy to afterwards, or you can just look at the code. But this does append children, remove child, all of those sorts of things. And we're finally at the end of our recursion. So we can pop some frames off the stack, work our way back up to set state, or that top level render. OK, that's it. We did it. Well, much like George Bush here, not really. So there's actually a whole lot of things we didn't cover. And this isn't all of them either. And so the point in bringing this up is that we've built sort of a very, very minimal React in, sorry, I've gone over 35 minutes. And it was still super complicated. There's a ton of complexity even in this. And so I guess the point is everything is awesome, except it's not. So we pay for a lot of this complexity. Every new thing we add in here, sometimes it makes React faster, sometimes it makes it slower. Either way, it makes the code more complex. And so this is why it's hard to grow contributors. Our code is super confusing. It's poorly named. Sorry, again. And so React might not even be the best use case. Raquel talked about this yesterday in her talk. She mentioned, React was forced upon her, and maybe it wasn't the right thing. And maybe React's not the right thing for you. There's a ton of great alternatives. We've got Vue, Ember, Cycle, Angular, even something super small like Preact. These are all great choices, but you're going to make trade-offs. And so if you want some of the things that are actually in React, feel free to use React or not. That's it.